If the moon is big enough to block the entire sun, then why can't you see it in the sky the night before a solar eclipse? Think about that for a second. You've been told your whole life that the moon orbits Earth, that it's always up there, that on eclipse day it slides right in front of the sun, and boom, darkness in the middle of the day. But here's what nobody talks about. The night before a total solar eclipse and people go outside, they look up, they want to see the moon, and it's just gone. The sky is clear. Stars everywhere, no moon, nothing. So where exactly did it go? And before you say, oh, it's just the new moon phase, I need you to stay with me, because that answer raises way more questions than it solves. And by the end of this video, you're going to be looking at the night sky very differently. Here's what we're told in school. The moon travels around the Earth, the sun stays far away, and during a solar eclipse, the moon passes directly between the Earth and the sun, blocking the light. Simple, clean, easy. But let's slow that down and actually think about it. If the moon is always orbiting Earth, it should always be visible somewhere in the sky, right? Some nights it's full, some nights it's a crescent. Sometimes it rises late, sometimes early, but it's always somewhere. So why, on the night before one of the most dramatic astronomical events in human experience, the moon completely vanishes from the sky? Scientists say it's because of the new moon phase. During a new moon, the moon is positioned between Earth and the sun, meaning the sunlit side faces away from us, so we can't see it. Okay, fine, accepted. But now here's where it gets interesting. If the moon is between us and the sun during a new moon, why don't we get a solar eclipse every single month? Go ahead, try to answer that. The official response is that the moon's orbit is tilted about 5 degrees. So most of the time, the moon passes slightly above or below the sun from our viewpoint. Only when the alignment is perfect do we get an eclipse. That sounds reasonable on paper. But here's the part they gloss over in every classroom, every documentary, every NASA press release: the size match. The moon is about 400 times smaller than the sun. The sun is about 400 times farther away from Earth than the moon. These two numbers cancel each other out so perfectly that the moon appears to be almost exactly the same size as the sun in our sky. Not close, not roughly, exactly. So perfectly, in fact, that during a total solar eclipse, the moon covers the sun with such precision that you can see the sun's outer atmosphere, the corona, glowing like a ring of fire around the edges. That doesn't happen with any other planet in our solar system. Not one. Mars has 2 moons. Neither of them creates a perfect eclipse. Jupiter has 95 moons. Same story. Saturn, Uranus, Neptune. Not a single perfect match among hundreds of moons in our solar system. Only ours. Only here. Only on Earth. Now, just pause for a second. Because this next bit, it's the part people never really talk about out loud. What are the odds, eh? I mean, mathematically speaking, astronomers have actually figured out that this sort of size match is so precise, it falls within less than 1% margin. And, well, they just call it a coincidence. A coincidence. The moon just happens to be the exact right size, at the exact right distance, tilted at the exact right angle. All of that just so it can create the most visually perfect astronomical event that humans have ever witnessed. And honestly, we've never found anything quite like it anywhere else in the known universe. Does that really feel like a coincidence to you? Because if it does, I genuinely want to know what you think a non-coincidence looks like. Look, I'm not here to tell you what to believe, but I am here to say that the whole just a coincidence answer, well, it's never really sat right with a lot of very smart people. And honestly, the questions don't just stop with eclipses. There are videos on this page that go even deeper. The moon's rotation, why we only ever see one side, what ancient records actually say about the sky that modern science, quietly ignores. If this video made you think even a little bit differently, hit follow, because the next one, well, it might completely change how you see everything above your head. Don't scroll past this. The next video is already waiting for you.